In this section, we'll explore how to reformat user interfaces for different display sizes like desktop, tablet, and mobile. What works on a desktop might not look right on smaller devices, so adjustments are needed. We will adapt the application from the previous section to handle different screen sizes using predefined boundaries where layouts change based on width. Resizing the application will trigger conditions to be met, and the layout will change. We'll focus on the QML type, LayoutItemProxy, which helps manage layouts dynamically. Note that LayoutItemProxy, introduced as a tech preview in Qt 6.6, may change in future versions. Create a new project called LayoutItemProxy, using the same process we followed in the previous section. Go to File, New Project, and select Qt Quick Application. Name the project LayoutItemProxy, and use the same project settings as before. Since this project builds on the one from the previous section, you can copy the application window along with its properties without modification. You can use your own project or refer to the reference project in the Git repository. However, we will change the window title to Hello LayoutItemProxy. Copy the assets into the project folder as before, and then add them to the project using the Add Existing Directory option. As mentioned earlier, we will define some breakpoints for this application. We'll define two example breakpoints, a tablet breakpoint with a value of 1000 pixels and a mobile breakpoint with a value of 600 pixels. You can experiment with these values later to see what works best for your needs. We'll also define some simple Boolean properties that will change as we adjust the window size, indicating which layout we should use. The first property is isDesktopLayout, which will be true when the window width is greater than the tablet breakpoint. The second is isTabletLayout, which will be true when the window width is less than or equal to the tablet breakpoint and greater than the mobile breakpoint. Finally, isMobileLayout will be true when the window width is less than or equal to the mobile breakpoint. Next, we can copy the thumbnail delegate we created in the Layout section. You can use your own project or refer to the Code Snippets folder in Section 04 of the Git repository. Let's set up the application structure. The main purpose of LayoutItemProxy is to allow you to define the items you want to be managed outside of any layouts, and then have each layout use LayoutItemProxy to target those items as if they were inside the layout. To demonstrate this, we'll recreate the items from the previous section in this application as child items of the application window. We'll then use LayoutItemProxy in various layouts to position and size these items differently for the desktop, tablet, and mobile scenarios. First, copy the flickable component from the layout project and paste it as a child of application window. You can remove any layout attached properties from the flickable. We will make a small modification to the grid layout here. For the desktop layout, we want 2 columns. For the tablet layout, 1 column, and for the mobile layout, 1 row. A value of -1 means not set. Next, copy the preview image along with all the labels we created before. So far, we have declared a grid layout for the thumbnails with a dynamic arrangement in their rows and columns, the preview image, and some labels. Next, we will define the 3 different layouts we want for desktop, tablet, and mobile, and see where the LayoutItemProxy fits in for arranging the items we've just created. Now let's build our desktop layout. For this, we will use a row layout, which will be visible only when window.isDesktopLayout is true. This means that this layout and all its children will only be visible when this condition is met. We'll give the row layout a size using anchors and set a margin with a value of 5. Inside the row layout, we add our first LayoutItemProxy, which will target the flickable. When the row layout is visible, the LayoutItemProxy will attempt to take ownership and visibility control over the flickable, displaying it inside the row layout. A key feature of LayoutItemProxy is forwarding any layout-attached properties to the target item. This allows the same item to be moved around in different layouts, with different sizing policies applied in each case. Let's set some additional layout attached properties to ensure the flickable fills the height of the row layout and set a preferred width to match the width of the grid layout that the flickable is managing. Next, we add a second item in the row layout, a nested column layout. Remember that a nested layout will always fill its parent layout by default. The first item in the column layout will be another LayoutItemProxy targeting the preview image. The preview image already has layout.fillWidth set to true and layout.fillHeight set to true, so we don't need to add them here. Finally, add a nested row layout with layout minimum height set to 40. This layout will contain 10 LayoutItemProxy components, each targeting one of the labels. Start with the LayoutItemProxy targeting the source title, and repeat the process for all the other labels. These components allow us to use the labels as part of the desktop layout, displaying the text underneath the preview image. Let's run the application and see what we have so far. Notice that when we make the window smaller, as we hit the specified size of less than 1000, the layout we declared becomes invisible, along with all its content. This is great because we can now define another layout to be visible when this happens. We can do this next by defining the tablet layout. This layout will be similar to the desktop layout, so we can start by duplicating it and then making a few adjustments. To keep our code readable, we can start by changing the comment in the row layout to tablet layout. Then, we can update the visible property by binding it to window as tablet layout to ensure this layout is only shown when the tablet breakpoint is hit. Next, let's promote the LayoutItemProxy for the preview image out of the column layout and into the parent row layout. Then, we can remove the inner row layout surrounding the label proxies, promote them to the column layout, and align the column layout to the top of the parent row layout by setting layout.alignment to Qt.alignTop. This means that in the tablet layout, the image info will be displayed to the right of the preview image. Finally, add a small left margin of 5 to every other LayoutItemProxy to indent the label value slightly underneath their headings. Let's run the application and see the results. Notice that the layout now switches as we change the window width, and the grid layout adjusts the number of columns accordingly. Finally, let's declare the mobile layout. We'll have a single column layout with the preview image at the top, followed by a grid layout containing all the labels and the thumbnails arranged in a row at the bottom. Start by defining a new column layout, binding the visibility to window.isMobileLayout, and anchoring the layout to fill the parent with a margin of 5. We can then create a new instance of the LayoutItemProxy for the preview image. Next, add a grid layout with 4 columns. This will be for the preview image information. We can just copy the LayoutItemProxy components from the desktop layout into the grid layout. For the source value LayoutItemProxy, let's set layout.columnspan to 3, so the text spans multiple columns as the URL is significantly longer than the other info. Lastly, copy the flickable LayoutItemProxy and place it in the mobile layout's column layout. Ensure it fills the width of the parent column layout and set its preferred height to match the grid layout's height. Finally, let's look at all 3 layouts and test the switching depending on the breakpoints we've set. First, the desktop layout, then the tablet layout, and finally our new mobile layout, where the grid layout arranges the items horizontally instead of vertically, and the source value spans 3 columns. The LayoutItemProxy type allows the reuse of items in different layouts without duplicating the items. It enables the creation of adaptive layouts that are very performant, as only the visible layouts are processed. Additionally, LayoutItemProxy can be used without layouts, for example, by anchoring them to different items. A mix of real items and proxy items is possible, as well as nested structures of layouts and items. However, you need to manually ensure that only one of any set of LayoutItemProxy components sharing the same target is visible at any given time. The LayoutItemProxy's parenting policy may lead to unexpected behavior, as an item's parent can change at runtime. Lastly, remember that the properties and behavior of LayoutItemProxy may change as it transitions from being in its tech preview state, so please refer to the documentation for updates.